So hello everyone, in this video we'll solve another LeetCode problem, and the problem name is number of subsequences that satisfy the given sum condition. So let us read the problem statement. So you are given an integer array nums and an integer target. Now you need to return the number of non-empty subsequences of nums such that the sum of the minimum and maximum element on it is less than or equal to the given target. And since the answer can be very large, you need to take care with the help of modulo, that is 10 raised to power 9 plus 7. So let us understand what the problem is saying. So problem is saying that you are given an array and you need to return the total number of subsequence from this array such that the minimum value in it, that subsequence, plus the maximum value in it should be less than or equal to the target which is given to us. Now what is a subsequence? Now subsequence is simply like let's say if we are given array 1, 2, 3, 4. Now subsequence is simply by we can get by removing in between elements in the array. For example, it is based on two conditions: either we should take a particular element or not take a particular element. So if we take first element, our subsequence would look something like this. If we are not taking the first element, our subsequence would look something like this. Now after taking first element, if we come to the second element, we again have two choices: either to take it or not take it. If we take it, our subsequence would look something like this. If we not take it, our subsequence should look something like this. Now this will go on. Now since the question is saying that we are not allowed for the empty subsequences, we will not consider the empty ones. So in the subsequences, the order of the elements or the position of the elements matter. But if you look at the question carefully, do we actually need to worry about the order in this question? No, we don't need to worry about the order in this particular use case. Why? Because question is just asking us for the minimum and maximum value sum checking part. Now here order doesn't matter. Let us say, for example, if we have subsequence something like this: 1, 5, 8, 9. Now the minimum here is 1, maximum here is 9. Now whether I take write this subsequence like this or I write this subsequence like this, it doesn't matter because my minimum and maximum would still remain same. So in this particular use case only, the order for the subsequence would not matter. So what we can do, we can just sort the input array, because that will help us solve the question. Now why? Because if you look at this, let us say we take this first example. So the array is 3, 5, 6 and 7. If we sort this, in this case this is already sorted. So if we sort this array, it would look something like this. Now target here given is 9. Now we need to find all the non-empty subsequences. Now that means we need to make sure one element is fixed. Now since we want to return like all the subsequence, what value we will choose that should be fixed? Obviously the minimum value we will choose that should be fixed, because for that minimum and maximum will be same, and we can just check by adding these two values that if it is less than or equal to given target or not. So what we will do, we will maintain two pointers, one for the left part and one for the right part. This is similar for like question as of the two sum problem, which is LeetCode like first problem. If you have solved that, now this question has become exactly similar to that problem. So what we can do, we can keep our minimum element fixed in our subsequence, since we don't need to consider the empty subsequences. So we can keep the minimum element fixed, because minimum and maximum in that case will be same, and like this is the best possible scenario to get the sum less than equal to target if we take the most minimum element. So that's why we'll be keeping the like left pointer intact to the minimum one, and we will keep it fixed. So for this particular scenario, we will not have two conditions, either take or not take. In this particular scenario, we will only have one option, that is to take. Now we need to check whether this nums of left plus nums of right is less than equal to target or not. Now what are these nums of L and nums of right? Nums of L is obviously the minimum and nums of R is obviously the maximum. So what we will do, this L to R range is now our subsequence. So we will check if the minimum element and the maximum element sum is less than or equal to target or not. If it is, we will add the total number of subsequence present to our answer. Now how will we do that? Now total elements present in this subsequence are like how many? So let me just redraw that. 3, 5, 6, 7. So my L was here and R was here. So this is the indexing 0, 1, 2 and 3. So how many total elements are present in between? It is R minus L plus 1 elements are present in between. Now how many subsequence can be possible between range L to R? Obviously we know that every element has two conditions, either to take it or not take it. So it can go to 2 to the power n. So for L to R range, we have R minus L plus 1 elements. So how many subsequence will be there? It would be 2 to the power R minus L plus 1, right? No, it is not that. Why? Because we are keeping the one element fixed. So we need to remove this one part, because for this we don't have two scenarios. We will only have one scenario, that is to take it. So in total between range L to R, the total number of subsequence we will get is 2 to the power R minus L. So we will get that and add it to our answer. Now if the condition is not followed, let's say if nums of L plus nums of R, this was the first condition, was less than or equal to target, then okay, we are good to go. We can just move our L pointer forward, because for this minimum we already found the sub array till the maximum range. Now we will move our L pointer forward to get this minimum till the maximum range, that is till 7. Now if this condition is not followed, then what to do? That means we need to shrink our range. Why? Because our sum is getting exceeded than our target. Now if our sum is getting exceeded, we need to minimize the maximum value, right? So in that case we will move R pointer towards the left part. So we will do R minus minus, and same way we will go on until and unless our R is less than or equal to our L is less than or equal to R. Until and unless this condition is followed, this process will be followed, and in the end we will be returning our total answer. Now if you still don't understand, no problem, I'll show you the entire dry run on this first example, and then we will look at the code part as well. So let me just show you the dry run part now. So let us take this example 3, 5, 6 and 7. So initially our answer is 0. Since we don't find any sub array, we'll keep our L pointer towards the 0th index. So let me just write the indexing, and R pointer towards the maximum value, that is index 3 value 7. So initially we will check if 3 plus 7 is less than our target is 9. So 3 plus 7 is 10, so it is not less than or equal to target. So in that case we will move our R pointer here. So till now our answer is 0, because this is not a valid subsequence from 3 to 7. So we are not counting any of them. So if we move our R pointer towards the left, what is our new subsequence? That is from 3 to 6. Now 3 is the minimum, 6 is the maximum. So sum becomes 9, which is less than or equal to 9. So we will add it to our answer. Now we will add what to our answer? We will add 2 to the power R minus L. Now what is R here? R is 2 here, and what is L? L is 0. 2 to the power 2, that is equal to 4. We will add 4 to our answer, so our answer will become 4. Now since we have, for this minimum we have find all the valid subsequences till the maximum value of R, so we will now move our L pointer forward. So our L will now come at index 1. Now we will again check if 5 plus 6 is less than or equal to 9 or not. So 5 plus 6 is equal to 11, which is not less than or equal to 9. So we will move our R pointer behind. So our R is also at the same position as of the L. So our R is also at the index 1, and L is also at the index 1. So again we will check in this case minimum and maximum are same, so 5 plus 5 is 10, which is not equal to or less than equal to 9, so we will not consider this array. So again we will move our r pointer backwards. So now our r pointer is here at the 0th index, but wait, L should be less than or equal to r. Here L is now at 1 index and r is at 0 index, so this condition fails. So that means we need to break our loop, and since we have nothing left to check, we will return this answer. So our answer we got is 4, and as you can see, the output is also 4. So this is how, with the help of 2-pointer technique, we will be solving this problem. So I hope you understand this dry run part and the explanation part. So let us directly move on to the code part. So this is the code. So this is similar to what I have explained. So this, I have initialized the num size as n, then I have taken the L pointer and R pointer, L to 0 and R initialized to n minus 1, that is the last index. Initialize the answer to 0, and I have created the power vector. Now why I have done this part? Because if you just take power of 2 comma r minus L, it will give you runtime error because it will go beyond the range of integer. So I have pre-computed by taking the mod, so that it won't give us the like runtime error. So it is just that part. You can try out without taking it, without taking this power vector. You will understand why that error is coming. So then you can like implement this power function as well. Then what I have discussed, we need to first sort the entire array. Since in this particular case only, we don't need to do anything with the order of elements in terms of subsequence. So we can just sort the array. Now after sorting, we need to continue our 2-pointer iteration until this condition is valid. Now what we will do, we will check whether our minimum and maximum sum is less than or equal to target or not. If it is, we are adding 2 to the power r minus L to our answer. So answer equals to answer plus like power of r minus L. Now why I have taken mod? Because it can go out of the integer range. So for safely for the safe scenario, we need to take mod, otherwise it will again give us the runtime error, since it will go to the out of bounds of the integer range. So you need to take mod while adding this as well. So after adding, we will be just moving with the L pointer, and if this scenario doesn't follow, then we need to move our R pointer backwards. In the end, we will be returning the answer. So I hope you understand this question. So thank you for watching.